Hello, I'm Phú from Group 6. I will be demonstrating the authentication functional group. Um, First, I will guide you through the UI. This is the login page, and this is the sign up page. Um, for the responsive, it works across all devices from desktop to mobile, and let me change quickly to this is what it would look like on a Pixel 7, and for iPad mini it would looks like this, and for yeah, it works perfectly fine. Okay, let me okay, I will be demoing the flow. First is the registration. I will be filling in the correct again. Oh, this confirm password is just a client side. It doesn't client side validation. It doesn't send anything to the server. Only the password and emails are being sent. And the register also have the visibility toggle to help you see what you just typed. I'm just change to the network tab real quick and to see how the response be sent after I register. So yeah. After a successful registration, I will be sent to the homepage, and I'm now logged in. Let's look at the network tab and the register request. Um, the response body has my user object, which contain my Gmail email. I just enter an access token, which is this access token is a JWT, and it is now stored in the JavaScript memory. And in the application tab in the cookie, you can see that there is a refresh token. This is how do you say? You can see that the HTTP only column is being checked, which means that this is the JavaScript cannot read it. So the browser then send it automatically, but it will only send to the auth endpoint. And this is how we protect against XSS attacks. Let me try the login, and this is just a profile object that be created when you register an account. When you log out, there would be a confirmation dialog can pop up, and after I click log out, the cookie the cookie would be destroyed clear. The session is destroyed server side, yes, and the cookie is clear, and I would be back to the guest state. Here you can no longer see the refresh token that was there just a moment ago, and the logout request would return 200. Okay. Yeah. Let me log in real quick. And here is the how the response the login is just the same thing with register, but now the response user has a new refresh token cookie. Okay, let me just show the diagram real quick. I will be talking about the auth flow using this diagram. Let me walk through how they work. First is the login section of the sequence diagram. When you click login, the front end validate using a dot schema. And this schema, this is the same schema that the backend uses. So that it then send a post request with your email and password. And the backend will then look up the user by email and then verify the password using bytecrypt. It's a one-way hashing algorithm. It doesn't store your actual password. It actually store the hash, and if the password is correct, the account would be set as active, and it would be sent. And the server would then create two tokens, a short-lived JWT access token. It will only live for 15 minutes, and then the access token that would contain your user ID, token hash, row, user ID, row, and status. And then the second token is the refresh token. It's a long-lived token that would live for 7 days, and it will only store in the HTTP only cookie that I just saw here. So, yeah, and then okay, on to the authentication request. So like every time you do something on a website, like posting a thread, like a post, leave a comment on, I don't know, do something, the front end would attaches the asset token to as the bearer header, and the backend would verify the JWT signature, then they read the user from database by to make sure that the account is still active. Here, and if the account is still active, why we do this check twice is because if an admin bans you mid-section, the next request would fail even though the token is technically valid. Yeah, so this is for that. Then why we need to check if the account is still active. Next is the token refresh section. After 15 minutes, the accept token would expire and the front end detect this automatically. And then it automatically calls a refresh endpoint. It sends the refresh token cookie, and the backend look up the session in the database, verify if it hasn't been revoked or expired. Then it would revoke the token and create a brand new it wouldn't revoke the token and create a brand new refresh token plus new access token. This is called the token rotation. Yeah, every time you refresh, the old token became invalid. So if someone still refresh token, it wouldn't work because it constantly being created in a rotation, right? Next is the logout section. So when you log out, the server would revoke. The server will set a revoke timestamp on the refresh section. Okay. In the database, it is just a soft delete. The row of that section will stay, but it's marked as revoke, and the cookie is clear, and the front end would wipe the access token from memory. Now I will go through the code. First, let me. This is the share schema. No, share, yeah, share schema. So this file defines the shape of our authentication request and the response body using ZOT. This is important for both the front end and back end, and so both of them use the same validation rule. The login request would require an email and a password. The register request would it requires email and password with a minimum of 8 character. Just a soft rule we set, and although we haven't really implemented the chain password request in the UI, but we also have this. It would require your current password and a new one, and then it validates if they are different or not. And the auth response is what would come back. And after you do something, it contains a user object with ID, email role, and status, plus the access token that you just see when I demo, when I log in. Next would be the front end stage management store. The store, the front end uses just stand for the stage management. The store would hold access token, and the access token, the user object, and the status. Here, role and status. There is a silent refresh function that would run on page reload. It calls the refresh endpoint and with the cookie, and if it's success, the session is restored. The session will be restored, and if it fails, you would be redirected to guest stage. This is how we deal with, like, after you closing a tab and reopening it, you will stay logged in. Yeah. Next could be the API layer for frontend. The API layer wraps the fetch call. This call function automatically attaches the access token from the store as a bearer header. It will also include the credential, so cookies, assent, and each or action like register, login, logout, refresh or change password is a function that calls each of the action is a function that calls the backend, and they would how will I say that? And each one has a React query mutation hook. Here, that each of them have a React query mutation hook, and I use logging. Oops. This hook would it would update the existing store on success. Yeah, Yes, đúng rồi. Yeah, đây, yeah. Moving on to the backend, let's look at the routes first. This route files define 5 endpoints, and over the slash API slash v1 slash out, and each row would have middleware stacks, a middleware stack 1, 2, 3, 4, 5, and the register and login in requires the user to be a guest, and you can log in if you are already logged in, and they will also have a rate limiting, like 10 requests per 15 minutes per IP. The validate body middleware where runs the same JOS schema on the server. If the validation fails, it would return error. Next is service. The service has the business logic. For login, it would look up the user by email, verify the password using bcrypt, and check if the account is active. And if it's not, then it would create both token, here, the refresh token and the accept token. For refresh, it passes the cookie into ID and secret, and then it would then hash the secrets and look up the session in the database, then revokes it, create a new one, and then issue a new accept token. So the old token will be gone and new token issue the token rotation. And for lockout, it's a soft delete that we talk about. It will set the revoke card. We set the revoke card to something that is not known, which is the date now. Let's talk about password. Yeah, password and changeability. Leave the password. Let's talk about password first. This is the bcrypt hashing. We use the bcrypt to hash password. This is one function is to hash and one function is to verify. And then the changeability, signing and verification. The asset token payload contain user ID, role, status, and it is signed with a secret key, and it has a 15-minute expiration. Next is the middleware. The require out middleware extract the bearer token from the authorization header, and then it reads the user from the database. Then, like I just talked about, this rereading step is deliberate to check if the account has been banned or suspended mid-session since the token was issued. And there is also the optional. It works the same as the required obligations for the guest. This doesn't block an authentication request, and it would use on public endpoint like viewing a feed. I'm gonna show you how our database now. Let's look at what is actually stored in the database. And this is the user account table. Let me refresh this real quick. This is a user account table, and each user has their own UUID and UUID and their email are stored lowercase, and a password hash by crypt hash, which you can notice that it starts with $2B dollar. This is a index, a bicrypt identifier, and a status and timestamps. The email column has a unique index on the lowercase value, so you wouldn't be able to register with something like test uppercase account email .com if test dot account email.com is already set. I mean, so that's why we store all of them in lowercase. And next is the refresh session table. Each row would represent one active login session, and the token hash column stores the SHA-256 hash of the refresh secret, not the secret itself. So if the database were hacked, attackers wouldn't be able to use the token because they don't have the secret. You should notice how the revoke at column there, when it's not null, the session is active, and when it has a timestamp, the session is revoked. This is soft delete. And let me show you how the refresh token real quick. You can see that I'm logged in right now, right? And the user ID, this is the user ID. It's the same with the account I just created. Yeah, and revoke at is now known, meaning that I'm logged in right now. So let me log out real quick to show you that how the sub delete works. I think it just glitched a little bit. Yeah, it glitched. But as you can see, the revoke app is now not known, so I'm not logged in anymore. Let me log in back again real quick to show that if you refresh the page, it would delete the old refresh token and revoke the old refresh token and create a new one. Oops. 42. Yeah, 43. Row 43 is now known, right? Let me refresh. Yeah, you can see there's a new row 44, same user account ID, and the old one, the old refresh token is revoked, and there's a new one. Okay, so to summarize, our authentication system uses short-lived JWT for verifying each request, and it would combine with HTTP only refresh tokens for session persistence. The accept token lives in JavaScript memory and expire after 15 minutes. The refresh token lives in a secure cookie and lasts for 7 days. So when one expires, the other get you a new one. The code is organized into 3 layers: shared schema that both the front-end and back-end would use, and a service layer with the business logic, and the database layer with 2 tables for user and sessions. That's our org and functional group demonstration. Thanks for watching.